Hello everyone, this is Pritika Patel working as an assistant professor in Computer Engineering Department of Mahatma Gandhi Institute of Technical Education and Research Center Navsari, which is affiliated by GTU and AICT. Now today in this session we are going to discuss about performance analysis and measurement, which is the topic of subject data structure of second year third semester. Now coming to the point, introduction to algorithm. First of all, what is algorithm? An algorithm is an essential aspect to data structure. A step-by-step procedure to solve a problem is called an algorithm. An algorithm should be easy to understand, write and debugging. By using algorithm, the data structure are implemented. An algorithm is said to be essential and fast if it takes less time to execute and consume less memory space. An algorithm states explicitly how the data will be manipulated. Now here in this figure, input is given and set of rules applied on given input to get expected output. So here as an output, finally we get the solution of the given problem. Now next is performance analysis. The process of calculating space and time required by that algorithm is called performance analysis. In computer engineering, there are multiple algorithms to solve a problem. When we have more than one algorithm to solve a problem, we need to select the best one. It helps us to select the best algorithm from multiple algorithms to solve a problem. To compare algorithm, we need to use set of parameters like memory required by algorithm and the execution speed of algorithm. Now, next is time complexity. Every algorithm requires some amount of computer time to execute its instruction to perform the task. This computer time required is called time complexity. So time complexity of an algorithm is nothing but the amount of time required by an algorithm to execute its instruction. Calculating the time complexity of an algorithm based on the system configuration is a very difficult task because the configuration changes from one system to another system. To solve this problem, we must assume a model machine with a specific configuration so that we can able to calculate generalize the time complexity according to the model machine. Now, to calculate the time complexity of an algorithm, we need to define a model machine. Let us assume a machine with following configuration. It is a single processor machine. It is a 32-bit operating system machine. It performs sequential operations. It required 1 unit of time for arithmetic and logical operation. It required 1 unit of time for assignment and return value. It required 1 unit of time for read and write operation. So these are the configuration for model machine. Now we calculate the time complexity of following example code by using the above defined model machine. Consider the following piece of code for given example. Here integer sum integer a comma integer b. So here sum is the function and integer a and integer b is the parameter of function. Now in function return value of a plus b. So here summation of a plus b is written by this function. So in given example code, it requires 1 unit of time to calculate a plus b and 1 unit of time to return the value. That means totally it takes 2 unit of time to complete its execution, and it does not change based on the input value of a and b. That means for all input value it requires the same amount of time, that is 2 unit. Now next is space complexity. Space complexity of an algorithm is total amount of computer memory required by an algorithm to complete its execution. The total amount of computer memory required by an algorithm, it is nothing but the space complexity. When we design an algorithm to solve a problem, it needs some computer memory to complete its execution. For any algorithm, memory is required for the following purpose. First one is to store program instruction, to store constant value, to store variable value, and for few other things like function call, jumping statement, etc. Now, generally when a program is under execution, it uses the computer memory for three reasons. They are as follows. First one is instruction space, second one is environmental space, and third one is data space. Now, what is instruction space? Instruction space is the amount of memory used to store compiled version of instruction. Then next is environmental space. It is the amount of memory used to store information of partially executed function at the time of function call. And last is data space. It is the amount of memory used to store all the variable and constants. Now, to calculate the space complexity, we must know the memory required to store different data type values based on compiler. So, according to the compiler, we must know the memory requirement to store different data types value. For example, the C programming language compiler require the following configuration. First one is 2 bytes to store integer value, 4 bytes to store floating point value, and 1 byte to store character value. Now, if we want to store the value of double, then we need 6 or 8 bytes. Now, here example of space complexity calculation is given. Integer square integer a. So here square is a function name and it's having parameters, that is integer a, and this function return square of a into a. Now in this piece of code, it required 2 bytes of memory to store variable a, and 2 bytes of memory is required to return value. So that means totally it required 4 bytes of memory to complete its execution, and this 4 bytes of memory is fixed for any input value of a. Now here worst case analysis. As per name suggests, In worst case, maximum time required for program execution. Worst case is the function which perform maximum number of steps on input data of size n. So, in worst case analysis, we calculate upper bound on running time of an algorithm. Now, what is upper bound? Upper bound means a number equal to or greater than any other number in a given set. Here, take example of worst case analysis for problem of searching element in an array with 10 elements. Here, array of 10 elements is given having element of 5, 1, 9, 6, 2, 11, 13, 4, 7 and 16. If we want to find the element 16, then it required 10 comparison because it is located at the end of array. Here if we want to find element 16, then what happen? We have to compare each and every element of array with 16. So first we have to compare this element 5 with 16, then 1, 9, 6, 2, 11, 13, 4, 7 and last 16. Now 16 is compared with 16 and we will find the 16. So behavior of worst case is n comparison. Now next is average case analysis. Average case analysis required average time for program execution. So average case is the function in which perform an average number of steps on input data of n elements. So in average case analysis, we take all possible inputs and calculate computing time for all of the inputs. Then sum all the calculated value and divide the sum by total number of inputs. For linear search problem, let us assume that all cases are uniformly distributed. So we sum all the cases and divide the sum by n plus 1. Now next is base case analysis. Base case analysis means minimum time required for program execution. Base case is the function which perform minimum number of steps on input data of an n elements. In base case analysis, we calculate lower bound or running time of an algorithm. Now what is lower bound? Lower bound is nothing but a mathematical argument which means that you can't hope to go faster than certain amount. Here take example of base case analysis for problem of searching element in an array with 10 element. Here array of 10 elements is given which having element 5, 1, 9, 6, 2, 11, 13, 4, 7 and 16. From this, if we want to find element 5, then it will found by first attempt. Okay, because it's located at first position. So behavior of base case is one comparison. Thank you.